It's showing that the temperatures warm up through about to the end of May, and then the monsoon arrives, it begins to cool, the monsoon begins to go away in September, and then the temperatures warm, but by October, November, the winds change direction and they begin to blow from the northeast, so the temperatures begin to cool again. So, this is the climatological temperature of Mumbai. So, you can already imagine that climatology is defined as the average temperature over many years. Okay? What do you expect in the month of January based on 30 years of Januaries or 50 years of Januaries? So, it is just an average quantity over time. Climate and climatology are average over a certain length of time. What is climate change? For that, you have to first understand what is climate variability. What is climate variability? You can see that in this temperature being shown from 95 to 2013, the maximum temperatures and the minimum temperatures are not the same, for example. So, some year like here 2005 or so was much colder, 2007 was even colder than that, and some year here 1997 was warmer than most other years, and so on. These are the variations from year to year, which we call natural variability, because we will come back and see that they are not necessarily related to what human beings are doing. What is climate change then is if the temperature over this period that we are looking at is increasing or decreasing. So, for that, let us look at temperatures over several cities in India: Chennai, Mumbai, Delhi and Bengaluru. Some records go as far back as 1882 and they extend to 2014. And you can see here that the long time series is smooth a little bit, but it does not matter. You can see that the temperatures seem to have warmed. The minimum temperature here is about 22.9 degrees and here it is 24.7 degrees. And for Chennai, it has gone from 27.9 to 28.8. So, this we say there is a change. The mean temperature over an average, or even if you look for average temperature for January or February or any particular month, it has gone up over this period. So, that's a change. Does that mean that we have to always look for 100 years? Not necessarily. We will see that climate changes on many different time scales. The causes of those changes and the time scale at which they happen depend on what are the causes for the change, what are the drivers, what are the forcings. This is what climate change is about. So, to learn about climate change that is happening now and the global warming, we essentially need to understand what are the range of changes that are possible in our climate. For that, we literally have to go back to when the whole system came into being. The solar system is about 4.6 billion years old. Earth is about 4.6 billion years old. Since then, the continents have evolved, they have moved around, mountains have formed, mountains have disappeared, oceans have formed, oceans have changed in shape, depth, etc. So, all those things also affect climate, but more importantly, the sun himself has changed over time. The sun, we will not go into the details, has become more luminous over time, which means the energy coming from the sun has increased over time, which also changes climate. So, here is a record of some sort of a mean temperature of Earth as differentiated from the current mean. So, you take the current climate, you estimate the past climates and you look at how warm or how cold the past temperatures were compared to the current climate, and you plot them as anomalies. So, what I used a new term here, anomaly, you probably are already aware what it means. It basically means if you expect average January to be a certain way by the climate or climatology of that month, if it is above or below that long term mean, then you would call it an anomaly. So, the mean global temperature right now is, let us say, about 15 degrees centigrade. Any deviation from this value in the past would be called an anomaly. So, we are looking at temperatures going back to about 65 million years here, and you can see that the polar ocean equivalent temperature change going back to when the dinosaurs were just going extinct. The period was called Paleocene. So, you do not have to worry about these, but if you are a geology buff, then you know this is Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene and so on. And you can see that the temperatures reached a very warm 12 degrees above the current climates in the polar ocean. Okay? Imagine how cold the poles are now. And they were that much warmer, 10 degrees warmer, which means there was no ice in the Arctic, there was no ice on Greenland, Siberia was not so cold, Antarctica had no ice and so on. And there have been blips like this thing called PETM, which is the Paleocene Eocene thermal maximum. We won't get into the details of it, but we will point to separate references or resources to understand those details. There is this warm temperature that persisted for a while, that is referred to as the Eocene optimum. And you can see that there is a cooling that went on for almost 30 million years. What are the causes for those? Okay, those are the things you need to understand why climate changed from such a warm state and cooled below almost to the current levels, and then it started warming again. So, at some point Antarctica started glaciating, which means glaciers began to grow on Antarctica. What would that have done to climate? How would that have affected the monsoon, for example? Okay. Then the temperatures got warm again during the end of Oligocene around 25 million years ago, and the Antarctic glacier began to thaw, which means it began to melt. The temperatures remained constant for a while, and then they have been cooling. But what you have to remember when we come back to this later on is that global warming is happening here at the end. So, we are in this long term cooling trend, and there are changes in the time scales at which temperatures are changing, and we are doing global warming at the end of this long cooling trend. So, we will learn about ice ages, why they come and go, and where at what stage we are in and at what stage we are heading to, and how we are changing that cycle because of what we are doing by the human activities and so on. So, there are various terms here that we will keep coming back to. This is called benthic delta O18, which basically means benthos means the bottom of the ocean, benthic means the bottom waters. Delta O18 is basically an isotope of oxygen. Oxygen you typically teach as having a mass of 16 protons, and it also has isotopes of 17 and 18, which means it has a couple of extra neutrons, and they are mixed together. So, depending on where the evaporation happens, where precipitation happens, where snow falls and so on, the amount of delta O16 versus O18 is different. So, in the past when we look at signatures of water at that time, looking at the differences in the O18 versus O16, we can infer the water temperature at the time and say something about how much ice there would have been. We will learn these details as we move along, but just remember that we use isotopes. So, I jumped a little bit to say that there are these kind of geochemical and biogeochemical evidences we use to reconstruct past climates. Okay, that is a lot of information, but each piece has additional resources that you can look up as we go along. Okay. So, let us focus a little bit on the more recent period of 500,000 years. So, this is time is going back here, even in the previous chart. I do not know if you noticed it. The time is going from 0, that is the present period here, 10 millions before, 20 millions before and so on, to 65 million years before present. Here we are going back about 500,000 years, and then we are adding a little extra scale here of the last 100 years or so. So, we are showing now more detailed variations in carbon dioxide, methane and temperatures over this period. Why are we doing this? Because we are slowly moving towards the main causes of climate change in the current period that we are interested in. So, in the last 500,000 years, you can see that the carbon dioxide in the atmosphere has changed by about 80 parts per million by volume at these time scales, but human activity has now increased it very rapidly beyond anything we have seen in this record. How did we get this record? We will see later on when we look at climate data that this comes from taking an ice core in Antarctica. Okay. So, there is a highly correlated variability in methane as well. Methane also, it turns out, can cause global warming. So, these gases that cause global warming, we call them greenhouse gases, as you may be already aware, and the temperature is changing pretty coherently with the greenhouse gases. So, the greenhouse gases have always been a part of change in climate, whether the climate change is driven by moving of the continents, changes in sun's energy or whatever. The effect on global mean temperature is almost always related to the changes in greenhouse gases associated with the driving forces. So, we will come back to how methane and CO2 are increasing, how the temperature is changing in response, and so on. If you are paying attention, you probably also notice that there are slow changes happening on 100,000 year time scales, and then there is a sudden jump in CO2, methane and temperature, then there is a slow decrease, there is a sudden jump up, there is a slow decrease, and so on. These are called abrupt climate changes. So, we will see why sometimes it varies slowly and sometimes it jumps up. And what does that mean for us? So, if we are changing climate, then we have to be sure that we are not creating a big jump all of a sudden. So, we will have to learn that. That is part of learning about climate change. So, that is kind of a broad overview of what climate is, what climatology means, what climate change means. There are changes happening on so many time scales. The causes and the drivers will be different, but first let us go back and try to understand what the basic climate science is. So, let us start by remembering that our earth is a sphere and it is tilted on its orbit around the sun, and it is rotating around its own axis, which means if you take a basketball, for example, or a volleyball and put a flashlight on it, you will see that the center of the ball will be more lit than at the top or the bottom because of the curvature. The same thing happens on earth when the sun's radiation is coming from far away. The rays are almost parallel, but the amount of area that is intersecting the energy is more in the tropics because of the shape of the sphere. The amount of energy being received for the same area is going to be less at higher latitudes, which means there is more energy being received per unit area, per meter squared, or whatever unit you want to use, compared to higher latitudes. Okay. So, then when you look at the amount of energy that is coming in and the energy that is going out, then you have to see, is there a place where there is excess energy coming in, and is there a place where there is energy actually being lost to space. Okay. That is what we will see. The net effect, of course, is we know that there are various processes being
Good evening, ladies and gentlemen. Welcome to the professional lecture series. We want to thank you all for joining us once again. Today, we're talking about climate science, the basic introduction into climate change. And we have with us the head of Department of Environmental Planning and Climate Change in Lagos State, who is already available to take us on the basic around climate change. In the course of the year, we will also go more deep into it, but today we'll start with the basic knowledge. Mr. Bankole, if you are ready for us, thank you. You can take over.
Good afternoon. I hope you can all hear me loud and clear. I'm happy to be here on this platform to share my little knowledge with every one of us. And I also want to say that the video that was playing before I came on is very is an expanse information about climate science. In fact, climate science is very large that most of us know little about it. But as we go on in our course, then we learn how to what it means and what it entails. And as for Lagos, we need all the information that we can have so that we'll be able to project and predict what is going to happen to us when we know the peculiarities of Lagos State. So I will just go to the little that I have today. I'll be sharing my screen. And I hope everybody can see my screen. I hope you can all see my screen. Can the administrator please confirm whether you can see my screen?
We can see your screen, sir.
Okay. Thank you very much. So I'll be talking about basic information on climate science. And as much as possible, I would like us to understand what it means. And then as we go ahead, we can expand on it. And like I said, there is little that we know for now. We are all trying to get the grasp of this new phenomenon. My talk this afternoon will be based on these following areas, trying to differentiate between weather and climate, and also see what we mean by global warming and climate change. Then we'll explain climate science and the implication of it to us, and how do we apply climate science to what we do, greenhouse gases and their effects, and so on and so on. And then there are some basic things that we also be learning today to understand what it means. So let's go to the first one. When we talk about weather and climate, what is a weather? How do we define weather? Here we say that weather refers to atmospheric conditions in the short term. And the key word here is short term. Weather happens within a specific period, like changes in temperature, changes in humidity, changes in precipitation, wind, and all those. That is the weather. For instance, now it is bright and sunny here. It can change and become cloudy. So that is weather. But when we talk about climate, we are talking about the condition that happens over a long period of time. That is the cumulative effects or average of weather patterns. We can say that in the last 10 years, what is the rainfall pattern of Lagos? Then that is when we are talking about climate. And global warming itself means an increase in the Earth's average surface temperature from human greenhouse gas emission. What do we mean by that? When we talk about global warming, it means that something is eating up the temperature of the Earth. Something is causing the Earth to warm up. And these things are what we call greenhouse gases. There are about 7 greenhouse gases. We will get there, we will understand what they do. They have their importance. And why have they now become a warming effect to the extreme to our climate, or to our environment, or to our world? Now, when we talk about, so now looking at it, you agree with me that climate and weather is not the same, because I said weather refers to short-term atmospheric condition, while climate is an average of weather patterns over a long period. So when we are talking about climate change, climate, weather, loosely people use the word interchangeably, but they are quite different. They are different because of the time frame. Weather and climate are not in the same time frame. So we should note that and not confuse what we are talking about. I've also explained global warming and climate change. And I've also said that global warming is as a result of greenhouse gas emissions. And when we join all these together, climate change then refers to a long-term changes in the Earth's climate, not in the Earth's weather. It's a long-term change that borders on the climate or a region on Earth. And this includes increase in surface temperature, because the whole thing about climate change is about increase in temperature, increase in sea level rise, increase in this, increase in that. I'm sorry, it's like I'm sharing the wrong, I'll stop sharing now. I'm sharing this. And look at my slide again. I'm sharing the wrong one. Sorry, just give me a while. I'm sorry for that. I have corrected myself. So let's go back to where we are. So now, having understanding of what climate change is, now let's look at climate science. What is climate science? Climate science investigates the structure and dynamics of Earth climate system. That is, we try to understand what is happening in the system, what is happening, why there is increase in temperature, why there is increase in sea level rise, how can we do a pattern to be able to predict what is going to happen in the next 10 years or in the next 20 years. Because one thing that we must know is that climate science will tell us that if business as usual is allowed to continue, then we'll continue to have increase in emission, which translates to increase in the Earth abnormally. So climate science or climatology seeks to understand how global and regional or local climate are maintained, as well as the process by which they change over time. In simple terms, climate science is scientific study of climate. Scientific study of climate. Now, how do we apply climate science into our day-to-day life? Climate science now have helped us to make a forecast of what is going to happen. For instance, for meteorologists, what they do is climate science. They try to forecast or about the effectiveness or the volume of rain that is going to come, how it's going to happen. How is the climate responding to what we are throwing at it? How is the climate responding to increase in CO2? How is the climate responding to increase in methane? How is the climate responding to water vapor? And when we gather all this data and we put it into different tools, there are several tools that climate scientists use. For instance, when we are doing the emission inventory for Lagos, what we use is called series. That's the tool that we use. Some people will use leap tool. So all these tools are just the mechanism that takes the information and give us what we are going to have, the pathway that we are going to have in the nearest future. Now, there's something that we call representative concentration pathway, RCP. RCP is talking about the concentration of greenhouse gases. So when we throw in the greenhouse gases into the tool, then it will tell us what is going to happen. For instance, we have about 4 levels of RCP. We have RCP 8.5, RCP 6.0, RCP 4.5, RCP 2.6. And there is RCP 1.9 now. For a layman, what does these numbers indicate? What it means, if you look at the graph, RCP 8.5 is in red color. What it means is that CO2, if nothing is done over a period of time from 2000 to 2100, if we allow the way we do our things to continue, the greenhouse CO2 will continue to increase in our environment. And when the CO2 increases in our environment, a climate scientist knows the impact of that CO2. But if we begin to do some mitigative action, put some system in place, and we're able to reduce the number of CO2 that we are releasing, that's when you have the RCP 6.0, RCP 4.5, RCP 2.6. That is, you deliberately make some actions to limit the emission of your CO2. And when you limit the emission of your CO2, it's going to tell you that when the CO2 is released, is reduced, then maybe the temperature will increase, maybe this and that will happen. This is a pathway or a projection that we use to stimulate what is going to happen in the nearest future. Let's look at this graph also. You know, I said climate change is a cumulative of weather patterns for a long period of time. Now, what this graph is saying is trying to tell us what is the volume of carbon dioxide in the atmosphere 800,000 years ago, and then 200,000 years ago, and today. If you look at the graph, you will see that the graph is undulating up and down, is skewed. But when I get to today and try to see that if we continue to go this way, continue to increase our carbon dioxide level, what will happen? And the answer I got is that we are going to have more than 400 ppmv. What is ppmv? Parts per million volume of CO2 in the atmosphere. And the implication of this is going to be very grievous to the environment. If there is increase in CO2 in our environment. Now, let's consider something. And this is where I'm going to bring to bear the importance of CO2 in the environment. This is a question for us to think about. Greenhouse gases make up just 1% in the air. Without these gases, what will our planet be? And I have options. I want to just look at it and click an answer in your head. If there is no greenhouse gases, how will our planet be? Will it be completely frozen? Will it be about 5.5 degrees centigrade cooler than it is now, or about the same as it is now? What is your answer? My answer is option A. Without these gases in our environment will be uninhabitable. Nobody will be able to stay without these gases, without these greenhouse gases, because they are necessary to keep the temperature of the earth at a condition that we can live. So, you know, if you go back to what I said these gases have their importance, but why have these gases turned against us? This is one of the importance of these gases, to keep the temperature of the earth at a level that we can manage. Let's consider the greenhouse gases now. I have some greenhouse gases here on the screen. Water vapor, which means about 3% of the greenhouse gases. The carbon dioxide, the methane, the oxide of nitrogen, ozone, the chlorofluorocarbons, the hydrofluorocarbons, and the perfluorocarbons. If you look at the graph on the left-hand side of the screen, that graph is telling us that water vapor stays long in the atmosphere. And the reason why it stays long in the atmosphere is because it helps to regulate the temperature. I'm going to show another graph. There is evaporation and precipitation. Water is being exchanged between the sky and the ground. Water is continuously moving. But if the rate of evaporation is not equal to the rate of precipitation, then there's going to be a problem. But on the other hand, carbon dioxide itself can stay longer period in the atmosphere. So what do we do? The more radiation we receive, the more warm the earth will be. So there is need for us to have a balance between emission and radiation. Again, look at the graph beside the test. Said Earth's surface receives radiation from both the sun and the greenhouse gases and clouds in the atmosphere. Radiation from the sun and then infrared radiation back to the sky. This is what we call the greenhouse effect. And there must be a balance if we want the earth to be warm enough for you and I to live. Let's look at the impact of climate change and take Lagos as an example. All of us understand what water cycle is: evaporation, transpiration, precipitation. Precipitation is when it is raining, and evaporation is the taking up of water from the surface. Now, what is the implication of all climate change to Lagos? Temperature. When the temperature increases, the hazard that we are going to experience is a lot of mosquitoes and malaria and heat stress, which means that it's going to impact our health services. And that is why today environment and health are collaborating, because whatsoever happens in the environment is going to affect Earth also. Another one is evaporation. The longer the evaporation, I said there must be a balance in evaporation and precipitation. If evaporation is more than precipitation, we are going to have extended harmattan, or what we call drought. And when there is drought, there will be food insecurity. And the other way around, if there is increase in precipitation, what we are going to experience in Lagos is extreme flooding. And the impact of it is that there will be loss of life and property. Now, sea level rise. Many of us don't understand what sea level rise, how it happens. Sea level rise, somebody will say that it is because rain is falling so much that the water level is increasing. Yes, you are correct. But have you considered that when there is thermal expansion of the water, what you have is increase in water. And once the water is increased, there will be coastal erosion and there will be damage. So what this thing is telling us is that we must be careful how we contribute to the number or the percentage of the greenhouse gas in the environment. Our behavior must change. The rate at which we emit these gases to the atmosphere must change. We must do something about it. Now, what are the responses to climate change? The way we can do is by reducing the rate and magnitude of change, by reducing GHG emission. When you burn your tire, when you burn your waste, what you are doing is you are increasing carbon monoxide, you are increasing methane. When you have a landfill site that is not properly managed, we know that methane are generated from waste management. And in Lagos, you agree with me, if we have to do the study and check the air quality or check the our waste dump, do a gas extraction, we'll see tons and tons of methane. What else do we need to do? We also need to, mitigate our action. And Lagos State has done a lot about mitigation. Building anchor-pods and groins along our sea coast. When you go to Bar Beach today, Kuramo Beach, you see the anchor-pods and the groins. When you go to Elegushi, you see the anchor-pods and the groins. These are mitigation action to stop the water from flowing to the community. But we must go beyond mitigation. We also do tree planting. BRT is also a mitigation action. But we must begin to now think, what has BRT brought to us? BRT has helped us in moving people from one place to the other. But has BRT in natural sense reduced our carbon monoxide level? The answer is no. Because our vehicles are still using fossil fuel. Then we must now begin to think about using other alternatives to fossil fuel. That is the only way we can reduce CO2 in the atmosphere. And we need to begin to do adaptation projects. Many people build in a wetland. We know that Lagos, there is no land for building. And we need to build. We need to do something about Lagos. People need to, United Nations said, everybody has a right to home. Fine, yes. If you must build on a waterway, you must build sustainably. Allow the water to flow underground. That is, your first floor must be an open pathway for the water to go. That is when we are adapting, not the way we are doing things. And not by cutting down trees, not by destroying our rainforest, not by destroying our mangroves. And that also brings to the fact that we must begin to use technology to respond to climate change. Lagos must be thinking now, do I have an early warning system? Because there's something that we call interdependency, which is not treated here in climate change. Interdependency means that when there is flooding, for instance, it's not only going to affect our road, it's going to cause traffic, number one. students will not go to school. Number 2, it's going to bring waterborne disease. Number 3, NEPA. Thank God for Nigeria. As soon as there is small rain or small wind, what do we have? Light outage. So interdependency means that one action will result into several implications. Every one of us needs to start responding to climate change in our little way. Now, I'm bringing it home to explain what other things that we need to know. Like I said, if we are to talk about climate science, we will not finish because I myself don't understand everything. But this is just a brief introduction to climate science. Now, what do we mean when we say global sea level? Global sea level rise is a consequence of glacial melt. And why is the glacier melting? There is increase in temperature. And why is there increase in temperature? Our action is increasing the greenhouse gases. The emission and the radiation are not equal. The radiation is more than the evaporation. Adaptation, what does it mean? It means to adjust or to prepare, to adapt to what is happening around us. We cannot change some things. So what do? We adapt to it. Adaptive capacity means the ability of that system to adjust to climate change. And all the variabilities, all the vulnerabilities, we adjust to it. Like, as I've mentioned, if you are building in a wetland, adapt. The ground floor, let it be an open pathway for the water to go. And then you start living from the next level. And anthropogenic means the actions that you and I, that we do. We are the one that is increasing the rate at which greenhouse gases are increasing in the atmosphere. So we need to consider our ways, our waste management ways, our building ways. Even we should be thinking of the materials that we use in building, because some of these materials are CO2 generating ingredients. We also need to understand that when we cannot adapt, we have to mitigate. Let us reduce greenhouse gas emission. What Lagos State has done is by planting trees, because we know from basic biology, trees depend on carbon dioxide and they release oxygen to us. Those carbon dioxide, when they take it in, they convert them to activated carbon that is stored in the ground. And another thing that we also need to understand, to know, is the climate system. How do we affect the climate systems? The atmosphere, the hydrosphere, the cirrosphere, the lithosphere. Because all this, variation in all this, in the atmosphere, is what we see. Hydrosphere is talking about water environment. Cryosphere is talking about the environment that is water but is iced, like the glacier, the Antarctics. And then resilience, we must begin, as a state now, begin to build the capability of the state to anticipate what is going to happen. We are too responsive. We are not, how do I put it now? We don't think ahead of time. Everybody will talk about Lagos being a below sea level, Lagos being vulnerable, Lagos being that. But what have we put in place to be able to adapt to this thing that is going to come? And finally, and this concerns each and every one of us, urban heat island. Sometimes when I listen to people talk about there is too much heat. Oh, we cannot sleep in the night. Oh, the sun is too much. Even at night, we don't have respite. then I begin to wonder, do we understand what we are doing? Do you understand that we are the one that is causing this so much heat at night? The way we build our houses are all concretized and they are close to each other. So when the sun is shining in the day, what happens is that the heat are trapped on the walls and on the ground. And at night, the walls and the ground will release the heat that have been trapped. And then we begin to experience heat in our environment. And then it's also talking about the number of cars and buses that we have. Everybody wants to ride their buses. You want to ride your cars. We must begin to think about intramodal form of transport system. Lagos State is moving towards that point, but we must also think, are we going to be dependent on fossil fuel, which is going to increase our greenhouse gases, or are we going to go for alternative? I think I will stop here. Thank you for listening to me. There are some references. Thank you very much for listening to me. I hope I've been able to impact little of what I know. God bless you.
Thank you. Well done, Dad. Well done.
Thank you, man.
Thank you, Mr. Bankole. The floor is open for questions, observation, and comment. I'd like to use this opportunity to thank my mommy for joining us. It's nice hearing your voice again. Thank you, Ma. The floor is open for questions, comments, and observation.
Thank you. I'm in school, so I had to learn. So, Teacher Bankole, thank you.
Thank you, man.
Well done.
Yes.
Be a question too is how we should, having been to COP26, we've heard that we have to stop fossil fuel, and we're in a nation where we think that's the source of our income, and we have sun here. If the sun comes out a little bit, everybody is maximizing it. What can we do to make sure that we have access to these alternative renewables and all that, so that we can have measurable change and we are not just speaking with both sides of the mouth, because we can't reduce CO2 with our mouths. We have to do something.
Thank you very much, Ma. I believe that because we are a country that generates its revenue from fuel, we cannot totally divest from fuel. And I believe that we need to be thinking seriously, because many of the European countries are already thinking of cars without petrol in the nearest future. So what do? We are not going to move away completely from fossil fuel, but we can have an hybrid of vehicles. There is a way we can convert our vehicles to use less of fuel and more of CNG. And then we can also try carpooling. Everybody does not need to put their cars on the road. And we need, thank God for Lagos State now, there is this non-motorized transport policy where they are encouraging people to bike. You mentioned about COP. While in London, I noticed something. There is a bike lane, and there is a meter counting the bikes. Many of them love to bike, not because they don't have money, but because they are conscious of the environment. And now in UK, what they have done, and some other European countries, is to designate some areas as emission-free zone. which means if you have to take your car through those zones, you have to pay some taxes. You have to pay some taxes. So here we must recognize, we must do all that we can, know that we are in perilous time. Climate change is here. You talk about Boko Haram, and people said it's political. Yes, it's political. But the beginning of Boko Haram insurgents into the south is climate change. Because climate change causes food insecurity. And they are looking for food for their animals. There is transboundary movement, which is increasing the diseases, the pathogens that are not normally found here in the south. So we must be thinking, each one of us, how do I reduce my carbon footprint? How do I help? And as I can see that many of us here are government officials, we must be thinking in our own area, how do we create a sustainable environment? We are going, whether we like it or not, our children are going to be here. So we must be thinking of what to do, the way we build our houses, the way we manage our waste, the way we manage our transportation. Those are the things that we need to do in bits and pieces. And then by the time you will know that everything will begin to come down little by little. Thank you, man.
Thank you, Mr. Bankole.
Thank you.
Gift, Pedro, can you add?
Thank you, sir.
Gift.
Good evening, sir.
Good evening, sir. Good evening, sir.
Yeah, I want to appreciate the lecturer and the presenter. Even though your time was very short, you were able to bring out meaningful points that will be useful to individuals and probably government. I will ask questions at the same time, contribute. I feel the level of advocacy on climate change to me in this part of the world is still very low. It's like the advocacy is just going around at the intellectual level. I want to ask, does it mean that the illiterate farmers, market women, those in remote areas, are they not also contributing to this menace? Because if our advocacy is within the intellectual level, how do we trickle this advocacy down to the common man who at his own level also contribute to this menace? I'm trying to talk about community and stakeholders engagement, because it's like when physical planning approve a project and those in Ministry of Environment, those who regulate the activities are not carried along. So how can we really assist in ensuring that all the stakeholders are involved? Then lastly, sir, how do we reduce people's vulnerability to the effects of climate change and vis-a-vis building their resilience against the impact of climate change, especially at the grassroots, where the vulnerability is very, very high? Thank you, sir.
Thank you very much, sir, for those observations. Now, starting from the first one, the advocacy. Lagos State is doing, I recognize that we do more of intellectual advocacy than the community one. But that is not to say that we are not doing the community advocacy within the communities in Lagos. Of recent, we've commissioned several studies to understand the life patterns of people in the informal settlements, what we rather call slum areas, to see how they contribute to the environment and how they contribute to climate change. And we have solutions that we are proposing that can be done. But apart from that, we also engage with them, we collaborate, we go to them and we talk. And one of the avenues that we have identified that is going to work greatly for us is to partner with NGOs, because NGOs have a wider reach than the government.
Mm-hmm.
So what we are doing now is that we are partnering with NGOs, and we are seeing how we can penetrate and then educate as much as possible. Of recent, an NGO on that deals with widows and empower them through farming came to us, and we have agreed to work together so that we can go to the interland and make a presentation to them, because most of them still depend on using firewood to cook. And do we stop them from using firewood to cook when there is no alternative? So these are the narratives. Government is trying to look at the alternative to them using firewood. Is it gas that we are going to ask them to use, or use effective cooking stove? There are effective cooking stove that their emission is not that much. So we are doing all this education. And then of recent, there's something that we started, adaptation, gender-based adaptation projects, whereby we go to different communities to teach women about smart agriculture, how they can increase their food, how they can provide for their families without, we shouldn't be buying vegetables. Apologies to those that are selling vegetables, but we shouldn't actually be buying vegetables. Everybody should be able to grow vegetable in their house. But many of them don't know, and this is an adaptation strategy. So we went to them and we taught them, and we have been monitoring them. Many of them have had success stories. Even my staff, there are testimonies that they are now eating their own vegetable. Now, the second part, I think you are asking about how we build resilience. Am I correct, sir?
Yes, sir. Reducing people's vulnerability and building resilience.
Now, in climate change, what you don't know, you cannot manage. And now that we have a knowledge, I'll give you an instance. One of the villages that we went to, we tried to look at their energy consumption level. And we found out that many of them are on generator because electricity, national grid does not get to them. So what did we do? Or what are we doing? We are looking for sponsors that is going to provide alternative power for them. Now, the people that we are talking to right now, we've not found up the arrangements, because we are trying to look at the naira and kobo. What are they going to pay? Are we going to increase their burden or reduce their burden? And also, Lagos State has a policy. If you are building your house, 30% of the ground of the land must be green. But what do we do now? Everybody is building concrete. Even on the wetland, there's supposed to be a buffer zone. So what we need to do is that government needs to increase or needs to enforce the law guiding, protecting our natural resources, our wetland. Everybody needs to know that our action is going to impact on another person, whether we like it or not. So we have identified some issues. Lagos State agriculture is doing smart agriculture. Earth is doing their bit, transportation is doing their bit. But I think when people understand the rudiment of the situation, they'll be able to adapt to it properly. I hope I've been able to answer the question, sir.
Thank you, sir.
Thank you. Yeah. Thank you. There's a question on the chat. Please, what materials do you recommend for building an environmental friendly homes? What are materials, or how do Lagos transit from joining cities where environmental friendly homes will be part of our culture? Invariably, how do we transit to green buildings? That's the question on the chat box.
First and foremost, we must encourage physical planning to make all the building codes public. Everybody must know about the building codes. Recently, they are trying to develop energy code. My office is involved. And then I know Ministry of Energy and Mineral Resources are trying to have this gas reticulation in estates. But apart from that, when we build our own house, every one of us, what do we think about? We think about maximizing the land. Nobody wants to build a small house. Now, an environment-friendly house is a house that will depend less on electricity for most part of the day. Do we build facing the sun, or we build backing the sun? We are supposed to build facing the sun. During the day, we don't need lights. We don't need lights to see around. Because the more energy you use, the more greenhouse gas is produced. And the space you give, ventilation, or the space between buildings also matters. Now, what we are building in Nigeria now is vertical homes. In developed countries, they are building horizontal houses. And why are they building horizontal houses? Each and every one of us, you don't need more than 3-bedroom flats. You don't need a duplex. You don't need 5-bedroom apartment, 10-bedroom apartment. Because whether you like it or not, the occupant of those houses, of those flats, will leave very soon. And it will be you and your wife, or you and your husband. So we should begin to think about building vertically and not horizontally. And then we need to also reforest. We need to plant trees around our home. Have green areas, so that by the time your building is emitting heat or emitting the greenhouse gases, then the tree is taking it and giving you fresh air. So I think with this, then we will get there. We need to reconsider the way we build our houses. When we need to use fresh air in the afternoon, let's use it. Open your windows, use the lights, stop burning generators, stop burning electricity. Energy consumption is, and then again, building our the way we use water. Somebody asked me a question, I think 2 days ago. Do you think that Lagos have water? We don't have water. We don't have fresh water. But all of us are trapping from the aquifer. We are building boreholes. That is another strategy, another bomb waiting to explode in Lagos. Thank you, sir.
Yeah, thank you for the comments. There's another question here. How can Ministry of Environment and Water Resources strengthen synergy with physical planning, especially in the areas of complying to climate smart buildings? How do we improve the synergy between Ministry of Environment and Ministry of Physical Planning and Urban Development?
I think it's about talking. We need to talk more. We need to present the facts. We need to begin to speak to situations, because business as usual cannot continue to go ahead, to go the way it is. There are some, when we did a report recently on Lagos vulnerability, climate risk assessment for Lagos. And then one of the, there is one area that was highlighted. We sent it to physical planning. And they responded to us that they needed area view of of the area so that we can go do a joint visit. And what we did was we wrote back to the consultant to provide us all those things that physical planning has requested for, so that we can go out and I think this is a right step in the right direction. We need to synergize more. We need to talk more, because environments may look so small to some people, but whatever action that every other ministry are doing right now, we are the one to mop up. And I always tell people, whatever you throw to the environment will throw to you in double fold. Not what you give to it, but it will double it and give it to you. Increase your water by 100 liters, environment will give you 200 liters. Thank you, sir.
Yeah, thank you. I'll just try to make a little contribution with regards to the synergy between Ministry of Environment and physical planning. And I think this has become something that is recurring in the sense that we find out that Ministry of Physical Planning are just, they are looking at the physical structure, and most of the physical structure, they have footprints on the environment. And if we don't take it to them, we have to take it to them. The facts are there, the data are there. When they do their master plan, when Ministry of Physical Planning put out their master plan and observation, comments are raised, it's become like, let's just do it. No real action. No real action. I don't think we can sit here and somebody says, okay, Lagos does not have a bicycle path. We don't have a lane. We want to do a train system, and we are demolishing building. When we are doing our master plan, there is a Ekpe master plan, there's Ikorodu master plan, there's Badagry master plan. Why can't they put those things in place now? The Ekpe is fast developing, Ikorodu is fast developing, Badagry is fast developing. Let's put the bicycle lane there. The master plan are being reviewed now. Let's put it there. Let's put it in Badagry master plan. We may not have the money. We may not have the money to implement them now, but let's put it there. We need to just make physical, like now, there are buildings coming up in Victoria Island and Ikoyi, 30-story building, 25-story building, and these buildings are not smart building. How do you approve a building in a mega city like Lagos, 2022, this present time, and they are not smart building? So we just have to take physical planning up on this, and it's something that everybody have to do. I think because we don't have any other question, any comments, we would like to end the program here. Next week, Saturday, is our main focus. That part of the thing we heard today is that we need to do more advocacy. We need to talk more. We need to carry the grassroots along. It's Easter period, and we believe most of us will be at the holiday mode. Our real talk show, the Eco-Environment talk show, will come up next Saturday, and it's going to be around climate change and the experience of COP26. What is the benefit for Lagos? What is the benefit for Nigeria? This is not a training program, neither is it, but that one is a general informative program for the citizens. So I will employ us to inform our members, inform our families, our friends. Next Saturday, 4 p.m. in the evening, we will have the larger audience to discuss about climate change in Lagos and put the state forward, and also make our contribution to humanity. Thank you very much for everybody that joined us. Mommy, thank you. We appreciate you. Mr. Bankole, thank you on behalf of all the participants. We really enjoy your lecture. Thank you. Thank you, everybody. We'll see you next
Thank
Saturday.
you. Thank you. Bye-bye.
Thank you. Bye-bye.
Bye. Thank you.
Bye-bye.